You sent me on the chat?
Uh, I'm sending. Is there no option?
You're asking about week 8 GA.
Uh, yes, week 8 GA question number 22.
Wait, let me see. Question number 22. 15, 16, 17, 18. But in week GA there are total 18 questions.
Sir, graded ungraded. Mm, No, we have uh around 24 questions. Okay.
Is my screen visible? So this
Yes.
which out this is week 8 GA, if I remember correctly. Tell me which question is. This question belongs to week 8, na?
This one. Be uh, just a little scroll up. There was a question 120. Yeah, program counter. Yes, this one.
So what is the exact doubt in this? In which part?
Oh no, this one is the another. I'm sharing link, drive link for that
Hmm.
in the chat.
Are you sharing, Chandan, or not?
I'm sad in this chat. uh, this chat
What chat?
in call messages
Acha.
in Gmeet.
Wait, wait. Acha, this question. If instruction add one is this, got it, got it. Question number 22. Okay. So, what is the exact issue in the question? Hmm. If the instruction add one,
Uh,
add
how
R1, R0, 1 is commented out and register R1 becomes 0 with the PC at address this. What will be the PC value after executing the current instruction? Okay. So tell me. Mm, did you try or not?
I tried, but I was getting that time 124 memory address, and I forgot to share the above one. Just not. The second link that I shared, that is the program, and in this program we have to modify whatever is said, and after that when I was doing them, I was getting 124 memory address. So how it is come to 120, I didn't understand.
Okay, so R1 stays 0 at address 0x108. Okay,
Yes.
but the current instruction will depend on R1. Okay, but since
Hmm.
R1 is 0, the with the branch which is taken, so the program counter won't go to the next sequential address, na?
Then
You are getting my point.
in the last that is add adding, in that program counter will stay there only, will not count.
No,
Mm, okay.
you get it why? Because R1 is 0.
Yes.
See, how can you think of a program counter as? Imagine program counter as a finger on a page, okay? Like when you
Hmm.
read something, na? So program counter only points out to the line or the instruction which CPU is reading. Right now it is reading at what address? Line number will be your address. So right now it's reading
Yes.
on 0x108. After
Hmm.
finishing one line, it should go to the next line
Hmm.
0x10C. But
Hmm.
the instruction at the previous line 0x108 was not a normal instruction, it was an if line.
Yeah.
Now, if R1 is 0, then jump to address 0x120. But since in the instruction what is given, add I R R1, comma R0. comma 1, which would make r1 as 1.
Yes, but that is still in the question. It was given that R1, comma R0, comma 1. That instruction will be commented out,
Yes.
so
So
it won't
that's why
executed.
so r1 remains 0 na.
Yes.
So that's so now the line now the line, if r1 is 0, which jumps to the address 0x120, that's why it jumps to that address.
Oh, okay.
Now you get my point.
Yeah, yeah, I got it. And one more thing that I have. mm,
Yeah, tell me.
Uh, Register write en in one question. It is was given in program that register white write en, uh, that is we have to see the value. What will be the value after at the end of the module
I
execution?
I'm not getting which question you are asking about.
Okay, I am sharing that one too.
Share the question. It will be better for me. You get the solution for the previous one, na?
Yes. I have shared that question. In that question, it was given at the end, register write en is not set, but the value will be 0.
Just
How?
give 1 minute. Let me just consider the following Verilog snippet. Okay. I don't remember the exact question. Let me solve it.
Yeah.
My screen is visible or not?
No, it's not visible yet.
It's not visible, no? Wait. Okay, tell me something. What would reg write en would do? What does that
Uh,
variable stores?
it stores I
So, if
one only
no, no,
in
eh,
one case.
so you are not understanding the meaning of this variable. So, reg write enable means if it is high, it means it will write something into the register. If it is zero, it means it would not. So, the variable would mean should I write something into the register or not? Is the simple thing. Now, for storing an instruction, we will won't be writing anything in the register then. We are just taking data from the register and storing it to the memory.
Hmm.
So in the code, the for the store case, the else part is the memory operation. So that's why reg write enable is never made one. So it default value should stay zero for store operation.
Oh, okay. I was confused because there is nothing mentioned about their default values.
No worries.
So I thought
Yeah.
it was
Mhm.
not there. Then it will show unexpected behavior.
Mhm. No, no, no. So
Okay.
any other doubt?
No.
Why no one has and no one else have joined the session?
I don't know about that.
If you have any other doubt, tell me, or you can leave the call. I will wait for some other 10 minutes.
Okay.
Yeah, Ravish, do you have any specific doubt or not regarding any assignment question or any concept I can explain?
No, sir. As of now, no.
Okay. So, Raja, are you all are having any doubt between week 5 to 8? Anything I can solve right now? Okay, if you guys are not having any doubt, then all the best for tomorrow's quiz. No doubt from anyone, na? Or anything. Sir, actually.
So it would be better if you summarize week 7 and 8 in one go.
Week 7 in one go.
Summarize just summary of whole week 7.
How can I summarize the whole thing? See, for I can tell you what's important, but I can't summarize the whole thing because see, everything is connected. I can answer your doubts like based on the graded assignment and everything. I will have
Okay,
to
so
then explain. So someone share me that link of week.
Uh, what link?
Share me the link of that NPTEL
Videos or
video link.
okay.
NPTEL Seek video link. Let me try.
Uh, okay.
So Raja, this is not the way that you haven't seen week 8 content and you will ask me to summarize it. If you have already read, then only it is of 2 hours only. Complete it and then I can summarize if you want. But summary I cannot give na of everything. Like professor, like where is that question? Someone shared it in the link on in the chat or not?
Raja shared the portal link and I shared the videos link.
Okay, Raja shared. So it's not opening for me. Let me open with the playlist. Hmm. So week 5, 7, 5 to 35.
Week 5 higher. It is from hierarchical design, like, and week 7 it is ALU. Where is it?
Okay, week 8 is ALU.
No, no, week 7 is ALU.
Week 7 is ALU, no? Okay. So I will let me start giving summary from this ALU week 7. Okay. If week 7 is ALU, ALU and then instruction coding. So you are aware of the formula of instruction coding or not? Like how deep I have to go? Just answer, give me something. Nah, I can't go just straight away. Okay, so if you're not, let me start. So in this lecture, we will focus on that. We focused on designing of the ALU plus register file data, which is used for computing and very simple processes. So what does your ALU stand for? Arithmetic logic unit. So what are our basic four mathematical operation? Addition, subtraction, multiplication and division. So we are are taking, let's suppose, input which is 8-bit wide and output will be also 8-bit of width. Now this small width can also what this small width will, what issues will face with this small width. Like whenever you do, like we have first of all the case in which overflow occurs, a carry occurs, or a borrow problem, which is based on addition, subtraction, multiplication, and division. In subtraction and division, you will have borrow problems. In addition and multiplications, you will have carry problems and overflow problems. Okay, so let's ignore for right now for those problems. For because the first four operations we will because for four operations, how many bit we will use? We will use 2 bit to implement. So 0 0 will be addition, 0 1 will be subtraction, 1 0 will be multiplication, and 1 1 will be division. Okay, in Verilog we will implement it as purely combinational with a case statement on control. Those 2 bits which I mentioned, 00 01 10 and 11, we called as op. So operation codes which will be defined using local param. Okay. Now the structure of ALU, I think you will be all be knowing. It has separate blocks for subtractor, adder, multiplier, and divider. But all the inputs remain same because it is operation is applied on A and B. Now, what gate you will use? What combination logic you will use if you have multiple options, and out of those options you will need only one. So you'll use multiplexer based on the your operation code. So if your op code is 10, it should select what? It should select multiplication. Okay, are you guys
Yes, sir.
understanding?
Yes, sir. Yes, sir.
So now the whole unit. So where I was on operation code. So
Sir, one thing, are you sharing your screen?
no, I'm not sharing the screen.
It would be useful if you do so.
No, I am just. I'm not reading from anywhere. Like you
If you,
want to write it.
yeah, we want to write it. So,
Array, it is better to look at the lecture from that notes. It is my handwritten notes. I'm reading from that.
oh,
Yeah,
fine then.
so I can't. It's actually what I'm going through now. It's very basic. Like this won't help you in exam. Main focus should be to watch the lecture. If you have watched, then you will connect with my whatever I'm saying.
Yes, I am connecting, but
Okay. So now, what is a critical path? Then tell me.
you,
Tell me what is critical path?
critical path is the longest sequence of project that determines the shortest possible time.
So where you read that definition? Hmm? So, definition is right. Critical path is the longest combinational delay. So, it longest combinational delay. Why do we talk about only critical path? Tell me that.
To identify the most important task.
No, no, no. Basically, what happens is critical path is important because for setup and hold violation. If your data is present, it has to be present before the setup time, before the clock arrives. Okay. So T clock, if clock arrives at 3 nanosecond and your setup time is 1 nanosecond, so your data should be there by 2 nanosecond. So what happens is to determine will it be there or not. If this at least before 2 nanoseconds it should be there. So what this means is if you have the critical path, then you will be able to determine everything. Based on that calculation you will do. You won't take the fastest path because fastest path will qualify. Okay. Now, path will go from now. Can you imagine because AB is input and OP will be on the select line. Now, one of the functional blocks, for example, is multiplier, which is the slowest. So, can you imagine this longer will be its path, lower will be the maximum clock frequency?
Can you say it again, sir?
Should I repeat it? You're asking
Yes,
that.
sir. Yes.
So I am asking longer is the this combinational delay path, lower will be its maximum clock frequency. It is true or not?
True, sir.
True or not? I'm asking.
True, sir.
So this will be true. Yeah, you are right. This okay. So what we want is we need the critical path that our longest combinational delay to be small as that so that our maximum clock frequency is better. Okay, so now as I earlier let us choose 8 registers so that each register address is 3 bits. Okay, if we choose 8 register then the address will be 3 bits 000 0011 00 like that. Okay, this is that's why you need a diagram. I don't have a diagram with me. Okay, if you go through the lecture it is exactly the same thing. In that the sir has showed a cross section, okay, of 8 registers. Now there will be two read ports, rs1 and rs2, and one write port, rd. Now only write port alone is not enough. We need an enable, reg write enable, and clock will be there, and the outputs is stored in rs1 data and rs2 data, which will later on feed the input to the ALU, and then you will get back the right data. So you are understanding this flow? from RS1 to write data? Yes, so I guess Ravish left the meeting when I asked him about the flow. So, Raja, is this fine for you or not? Like, are you writing it in the chat or not? Fine. Okay. So that's how you. So now for discriminant computation, what happens? For R0, you have to assign A, R1, you have to assign B, and R2, C, and R7 has 4, constant 4. Your temporary register will hold what values? Intermediate values. So R3 is B into B, R4 will be A into C, R4 will be R4 cross 4, which is using R7 because R7 was 4 earlier. Now your finally discriminant will store what? R5 is equal to R3 minus R4. Okay. So here is a concept we will call register reuse. In this, some register values will be overwritten once their old values are not no longer needed. Okay, so this helps us save some bandwidth. Now timing view is how can a time you can see a timing is after a clock edge there will be control logic which produces RS1 address, RS2 address, RD address, ALU op and reg write enable, and everything obviously must stabilize before the next clock edge to meet the setup. So the data path will look how register file to ALU to again register file. Okay. Control signals. Acha, what are the control signals? One will be the address definitely with which you are controlling. One will be the opcode in the starting, and one is write enable, which will tell you to store or not. That exactly which decides what operation is done. Okay. So that's this is one of the summary you guys wanted. So was it fine or not? Raja, let's do one thing. You complete week 8 and I will summarize it to later because if I give you summary na it won't be of any issue. Okay, just text me on Google Chat. We will connect and we'll have a separate session. I will summarize it. But it is not a good thing to first hear about the summary. It is only of 2 hours. You can do it. You know you have a lot of time. Okay, fine. Okay, Raja. So let me close the session. Thank you, everyone.